right. Let's start talking our way through this. So first thing they want us to do is graph and label segment TJ. So one of the things I just wanted to remind you guys about, the first number that you see in an ordered pair, that's telling us how far left or right from the origin. Second number is telling us how far up or down. So T at 4, 5 would be 4 to the right and 5 up right here. So here's my point T. And then J, positive 3, so 3 to the right, and then positive 2, so 2 up. So from the origin, 3 to the right and up 2 would be right here. So here's my point J. And then I'm going to grab my straight edge and I'm going to connect those two dots to get my line segment. We do not go past those two dots. The notation over TJ up here, if you look at that, it does not have arrows. If it had arrows on the end, then we would continue past those points and we'd put arrows on it. But because it does not have any arrows here, we stop at these two endpoints. All right, part 2 says that we are going to translate segment TJ by the rule, and then it says x, comma, y with an arrow. It says we're going to take all of our x's and minus 6 from them. My x-axis goes left and right. So if I take my x's and I minus 6 from them, would I be going to the right or to the left? To the left. So this is telling me it's going to go left 6. And then over here it says y plus 1. So that means what? I'm going to move it which way? Up 1. So I can either come over here to the graph and I can count. I can put my pencil down and I can go left 1, 2, 3, 4, 5, 6 and up 1. Or I can do this with the ordered pairs. To go left 6, I'm going to minus 6. To go up 1, I'm going to plus 1. So I can do this to my ordered pairs to get my image T prime, J prime. T prime, 4 minus 6, that would be negative 2. 5 plus 1 would be positive 6. So T prime is going to be over here. And if I count 1, 2, 3, 4, 5, 6, and then up 1, I get to the exact same place. So counting or using the ordered pair method, either one of those is fine. J prime, let's see, I have 3 minus 6, so that would be negative 3. And then 2 plus 1, that would be positive 3. So negative 3, positive 3 would put J prime right here. And again, if I count from J, 1, 2, 3, 4, 5, 6, and then up 1. Grab my straight edge and connect those 2 points to make my line segment T prime, J prime. Ooh, I lost the prime on my T. Sorry guys, that should be T prime, not T. Number 3, we didn't have to graph this at all. They tell me where the points G and P are, and then it says to translate segment GP using this. This is vector notation. We talked about this Friday before break. It gives me the exact same information as the notation up here in number 2, where it had x minus 6 and y plus 1 inside parentheses. I don't have parentheses here. I have these angled brackets. And when I see those angled brackets, I know it's telling me my x's are going to change by this much and my y's are going to change by this much. Since the x part over here is a positive, which way do you think we'd be going? Right, 3. So that would be exactly the same as x plus 3. The y part of this angle bracket is a negative 4. So what do you think we'd be doing there? Down 4. So that would be all of my y's minus 4. So I'm going to take my x's and I'm going to add 3. I'm going to take my y's and I'm going to minus 4. X plus 3 and y minus 4. So G prime would be at 0, negative 1. And P prime would be at positive 1, positive 1. Nice work on the warm-up. As a reminder, the homework that you guys got on Friday before break, that's due tomorrow. If you need another copy of it, please raise your hand towards the end of class, and I'm happy to bring that around. Sorry. I will get that out to everybody that needs an extra copy of that. The front side of that homework is going to be stuff like this. We're going to be translating points and segments and triangles. You're either going to see it written out in words, how far you need to move it. You're going to see it written in the notation here in number 2, or you're going to see it in vector notation here in number 3. One of those 3 ways of representing the translation. The back side of the homework that's due tomorrow is going to be what we're working on today. I want you guys to go ahead and pull out the notes that we started Friday before break. And if anybody needs an extra copy of those notes, or if you were not here on Friday. Okay. Take one, pass one back. And here's the one. Take one, pass one back. When you need one. When you need one. Here's the homework that's due. You need one? Okay. I've got the homework and the notes. Oh, just the homework. You'll have yours. Awesome. Should say module 4 notes up at the top. You found yours? Does anybody else need another copy of the module 4 notes or the homework that's due tomorrow? Awesome. You're welcome. Okay, so we're going to talk about reflections today. Translations was before break. That's what we just reviewed how to do on the warm-up. When we talk about reflections, this is going to be a flip or a fold over the line of reflection. Reflections do not preserve orientation. When we talk about preserving orientation, if something has the same orientation, then it has the same relationship to the other points there. So for example, here on number 2, I have this triangle. G is the farthest to the left point, and it's up fairly high. It's the highest point as well in that triangle. If I was going to preserve the orientation, then no matter what I do to this triangle, G would continue to be the farthest to the left and the highest up point. Well, when I reflect over an axis or over a line of reflection, it's not going to stay that way. Let's go ahead and look here at number 1. We are going to reflect this line segment, CD, over the x-axis. We practiced this a little bit on the Friday before break. When I reflect over an axis, whatever axis I reflect over, that part of the ordered pair stays exactly the same. So all of the x's in my ordered pairs are going to stay the same. The y's are going to change sign. So let's name these ordered pairs. I have point C and point D. Point C is over here at -5, 7. And point D is down at -3, 1. Since we are reflecting over the x-axis, my x's are going to stay the same. So in C prime, my x will still be -5. And in D prime, my x will still be -3. The y components of these ordered pairs are going to change signs. So since this 7 here is positive, in C prime, that's going to become a -7. In point D, the y part is 1. So in D prime, it's going to change sign to become -1. So -5, -7, C prime would be down here. And -3, -1, D prime would be right here. And then I'd grab my straight edge and connect those 2 points. It should look like if I were to take a piece of tracing paper and lay it over this and copy this onto my tracing paper, if I folded it right on the x-axis, D would land on top of D prime and C would land on top of C prime. When I talked at the beginning about preserving orientation and that reflections do not preserve my orientation, notice over here point C is the one that's the highest up and D is further down. But when I reflected it over the x-axis, now D prime is the highest point and C prime is the lowest point. So my orientation was not preserved because C and C prime are not both the highest points there. Number 2, I'm supposed to reflect this one across the y-axis. Well, when I reflected over the x-axis, that meant x stayed the same and y changed sign. What do you think it's going to mean when I reflect over the y-axis? Y stays the same. So my x will change sign. But the y's are all going to stay the same. So we have points G, F, and H. And I realized that I forgot a little line down here for G prime, so we're going to add a line for G prime. Point G is at -5, 6. Point F is at 4, 5. And point H is at 2, 1. My x is going to change sign, but my y is going to stay the same. So what would G prime be then? 5, 6. What about F prime?
7, 6.
F. -4, 5. And what will H prime be? -2, 1. All of the x's changed signs, all of the y's stayed the same. All right, so 5, 6 is going to be right here. G prime is over near where my original point F was. F at -4, 5 comes over here, so F prime is very close to my original point G. And H prime is going to be right down here at -2, 1. And then I'm going to grab my straight edge and I'm going to connect those points to make my reflected triangle. right. Nice job so far. Number 3, first thing that we need to do on number 3 is to graph the triangle that they are describing here. So we're going to graph triangle HIJ. H is at -8, -7. Right down here. I is at -6, -1, right here. And J is at -3, -5, right down here. Grab my straight edge and draw in triangle HIJ. We're going to take triangle HIJ and we are going to reflect it across the y-axis. So if I'm reflecting across the y-axis, what changes, what stays the same? X changes. And y stays the same. So H, instead of being -8, -7, is going to become +8, -7. I prime, instead of -6, -1, it's going to be +6, -1. J prime, see J was -3, -5, so we're going to have +3, -5. So +8, -7, here's my H prime. +6, -1, right here's my I prime. +3, -5, here's my J prime. And then connect those points to make my reflected triangle. Reflected across the y-axis, so if I were to have this on tracing paper and I folded it on the y-axis here, it should land on top of itself. Right, now I'm going to take that triangle that we just worked with, H prime, I prime, J prime. We're going to reflect that across the x-axis. So talk to me about what changes, what stays the same. If I reflect across the x-axis. Yes, x is going to stay the same. Y is going to change sign. Well, H prime was 8, -7, so H double prime will be +8, +7. I prime was 6, -1, so I double prime will be 6, +1. J prime was 3, -5, so J double prime will be 3 and +5. All of my x's stayed exactly the same as H prime, I prime, and J prime, and all of the y components changed their signs. So 8, 7, my H double prime is up here. I double prime at 6, 1 is going to be down here. And J double prime at 3, 5 will be right here. And then I connect my points to make the second reflection of my triangle. The first reflection, we reflected over the y-axis. This second reflection, I'm reflecting over the x-axis here. What about if I want to reflect over something that's not an axis? Let's look down at number 4. We're going to reflect, but this time I'm going to reflect across the line x equals -2. That means it has to touch the x-axis and it has to go through -2 on the x-axis. That means this will be a vertical line. So -2 on the x-axis. We are going to reflect over this line right here. When I'm reflecting over something that's not an axis, I don't have a nice pretty rule for that. I'm just going to have to count on my graph. So I'm going to take all of these points, M, N, and O. They're all on the right side of this line. We're going to reflect over here. So however far away it is from this line, x equals -2, however far away my points are there, they're going to be the same distance but on the other side. My height of these is not going to change. So like right here, point M, that is 2 units away from that line on the right. So I'm going to go 2 units away on the left. Right here is where M prime would land. At -4, -1. N is all the way over here. I need to know how far away that is from the line. We're not going to go up or down at all, but I am moving to the left. 1, 2, 3, 4, 5, 6, 7. I'm 8 units away. So I'm going to be 8 units away from that line on the other side. 1, 2, 3, 4, 5, 6, 7, 8. So right over here is where N prime will be. That's over at -10, -2. And then I do the same thing with O. O is right down here. We're not going to go up or down at all, but I need to know how far away from that vertical line we are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to go 9 units away on the other side on the left. 1, 2, 3, 4, 5, 6, 7, 8. I need to go 1 more, so I'm going to go 1 off my graph over here. So here's O prime. Most of the time our points are going to land on the graph. Every now and then when we're doing reflections, we're going to land just a little bit off the graph. So since I'm 1 unit off the graph, that would put O prime at -11, -6. And I want to grab my straight edge and connect those points to make my triangle. Number 5, we need to graph our original line segment. And then we're going to reflect that line segment across the line y equals 2. So let's just start with graphing our line segment here. -1, -1 for t. And -6, -3 for point S. And I'm going to connect those points. We want to reflect across the line y equals 2. That means it has to touch the y-axis at 2. It never touches my x-axis because there's no x here. So that means this has to be a horizontal line. So I'm going to go find 2 on the y-axis. That's the line that we want to reflect over. So how far away is t from that line? How many hops would it take me to get from t to that line? 3 hops. I'm not moving left or right at all. I just want to go straight up to that line. So 1, 2, 3. So I'm going to go 3 units on the other side now. 1, 2, 3. Right here is where t prime would be. How many units away is S from that line? see, 1, 2, 3, 4. We are 5 units away this way. So then I'm going to go 5 units away on the top side. 1, 2, 3, 4, 5. Right up here is where S prime is going to be. Grab my straight edge and connect those points. So T prime, T was at -1, -1. We didn't move left or right at all, so my X is still -1, but now it's up here at 5. S prime had been at -6, 3. We're still left 6, but now we are at +7 for the Y value. S used to be the lowest point. S prime is the highest point now because we've reflected over this line here. Whether it's an X equals or a Y equals. If it's X equals, it's always going to be a vertical line because it's telling me it touches the X axis, but it never touches the Y. Well, the only way it never touches the Y axis is if it goes straight up and down. Same thing here with a Y equals. Touches the Y axis, never touches the X axis. So it has to be horizontal. Good question. All right, let's flip this over on the back side. We're going to talk about 2 more rules here. When I reflect across the line, Y equals X. The point A, B becomes B, A. So I take the numbers that are in the X spot and the Y spot, and I flip them. When we reflect across the line, Y equals -X, if my original point was AB, it's going to switch, but it's also going to change signs. So when we're reflecting over Y equals X, we're going to switch the X's and the Y's. When we reflect over Y equals -X, we're going to switch and they're going to change sign. That does not mean that these will always be negatives here. If my original point had a negative in it, then it's going to switch over here and become a positive. If my original point had positives in it, then it's going to switch over here and become negative. Whatever the sign was originally, I'm going to switch the order and I'm going to make it the opposite sign that it was before. Right, let's practice that a little bit. All right, when we reflect across the Y-axis, this was front side stuff. Does anybody remember what changes and what stays the same when we reflect over the Y-axis? Yes, X is going to change. And Y is going to stay the same. So if my point M was 4, -7, where would M prime be then? -4, -7. What about when I reflect over the X-axis? What changes, what stays the same? X stays the same, so that's going to be 4. What about my Y's? That's going to change sign. So it won't be -7 anymore. It'll change to a +7. When I reflect across the line y equals x, we are going to switch the order of those numbers. So instead of 4, -7, I'm going to flip it around the other way. That would become -7, 4. When we reflect over the line y equals -x, we're going to switch it around. And we're going to change the signs. So we're going to go all the way back here to my point M. First thing I'm going to do is flip it. So -7, 4. But then we're going to change those signs. So 7 would become a positive, and 4 would become a negative. Yes, sir.
So it's equal. You change, you do both.
For which one?
Like when it's equal.
When it's equal.
Like the equal sign. Or switch.
So when y equals x, when it says those two things are equal, that's when we switch the x and the y. Yes. When it's y equals -x, I switch it. And we're going to make it the opposite signs that it was before. All right. Last two down here, we're reflecting over some different lines. We're reflecting over y equals -8 and x equals 1. Let's look at this one first. Because we're not going over an axis, I'm just going to have to count. So I'm going to draw a quick sketch off to the side for myself here. Here's my x-axis. Here's my y-axis. Point M is at 4. 1, 2, 3, 4, and -7. 1, 2, 3, 4, 5, 6, 7. So right here is my point M. Y equals -8. It's going to touch the y-axis, but not the x-axis. So here's y equals -8. How far away is point M from that line? Just 1 unit away. It's 1 unit above, so I want to go 1 unit below. M prime would come down here. If this is 4, -7, where's that point at? 4, -9. And then for the last one here, part F, we're going to reflect over the line x equals 1. This is going to be a vertical line because it touches the x-axis, but not the y-axis. So we're going to reflect over this line right here. How far is point M from that line? How many hops away? That's at 4, -7. That's at 1. 3 hops. 1, 2, 3 hops to get here. So 1, 2, 3 hops on the other side. That's where M prime would be. I'm not still over here at 4. Now it's where? -2. But we didn't move up or down at all. So it's still at -7 there. Let's look at number 7. We have this triangle, GFH, and we're going to reflect across the line y equals x. What's my rule for reflecting across y equals x? Yep, it's going to flip. It's going to switch. Where is point G right now? What's the ordered pair for point G? -4, 4. So where will G prime be? 4, -4. So it's going to be over here now. G prime is going to be down in the lower right corner. Where's point F? -1, 4. So where will f prime be? 4, -1. Right here. Where is h at? -5, 1. So where will h prime be? 1, -5. So down here is h prime. Grab my straight edge and connect those points. The line y equals x is this perfectly diagonal line right here. That's what we're reflecting over. So if I were to fold it on that line, G would land on top of G prime, F would land on top of F prime, and H would land on top of H prime. At any point, if you guys want tracing paper, I am more than happy to provide you with some tracing paper so that you can make these folds. Y equals -x, by the way, is also a perfectly diagonal line, but it goes the other way. Y equals -x looks like this. Because of time, we're going to skip 8 and 9, but I do want to go down and look at number 10. And that'll finish us out for today. Which statements are true about the reflection of an object? Was my orientation preserved? Was my orientation preserved when I reflected? Let's go back and look here. Here, G is one of the highest points. G and F are the two highest points here. When I reflected it, are G prime and F prime still both highest points? F is. G, like these are horizontal to each other here. When I reflected it, they became vertical to each other. Was my orientation preserved? Orientation is not preserved when we do reflections. All points are moving the same amount. Did point G move the same amount as point F? No. G moved the farthest because it came all the way down here. So my points didn't move the same amount. Distance of the object from the axis of reflection is preserved. Let's go back and look at one of these line segment ones. T was 3 units below the axis of reflection. Here it's 3 units above. S was 5 units below. Here S is 5 units above. Did the distance of a single point stay the same away from that axis of reflection, that line of reflection? Yes. The sign of the x and the y coordinates stays the same. No. Angle measures of the triangle are preserved. Let's go back and look at one. If I were to measure angle G here with a protractor and I would know how many degrees it is, would that be the same as angle G prime? Yes, so that is preserved. Nice work today, guys. Don't forget that homework is due tomorrow. If you need another copy of it and you didn't get it from me earlier, please let me know before you leave. Front side is translations, what we reviewed on the bell work, the warm-up, and what we did on Friday before break. The back side is reflections, what we learned how to do today. If you guys want any tracing paper, please let me know. I'm more than happy to provide that. I hope you have a great rest of your day, and I will see you guys tomorrow.